just like desperate now. I just sit down, you know? Yeah. I feel like before is something else.
Okay, so guys, today largely I just wanted you guys to practice the logistic growth thing, but I wanted to get through 1A and B. That there's like 7 parts to A. So logistic growth, this one says, okay, we have more bears, and they grow this logistic growth. Given that the initial population of bears is 100 at time 0, what's the limit as t goes to infinity of the population? So how do we find that? Like what do we do?
It's like 5 divided by.
Do what? Camden, suggestion? How do I answer part A?
Take out the 0.
Okay, guys, I can't hear. So we need to factor. What did I ask you guys to memorize yesterday? Yeah. So love that I'm being recorded with that. Okay, so that I can read off some variables, it'd be helpful if I was able to get things in that form. And I don't know about you guys, but I really don't deal well with the decimals. How do I turn that decimal into a fraction? 2 over, and the number of places you needed to move the decimal is the number of zeros we're going to put on there. And Camden said factor that out. Is that what you said?
Yeah,
2 over 1,000, which is 1 over 500. How do I factor that out? So, like by pulling out a divide by 500, aren't I multiplying by 500 on the inside? Okay, so let's just make sure we did that right. If I multiply this out, 2,500 divided by 500 is 25 divided by 5, which is the 5, and then the p goes with it, and then 2 over 1,000. So does that work? Okay. But Preston, why did Camden say that was how we started? How does that help us answer part A? What is M? So what is the answer to A? 2,500. So when you get it in the form that you can start to identify the variables in there, this is logistic growth, so the population K is some special coefficient specific to the population. In this case, the species is bears. M is the max carrying capacity. The reserve can handle about 100 of them, but once you get over that, they start to fight each other. Okay. And I don't like this wording, but this is from the goddess of calculus. Like, nationally, her files are shared with every calculus teacher on the planet. She uses the words, what is the range of the solution curve? And by that, she means from the time that we found these animals, what are the solutions? And we found them, there was 100, max carrying capacity is 2,500. And there is a point to this. I feel she must know something with AP that when you're asking for the range of the solution is from when we found it, what do we do? Yeah, 8 hours. Could be close, doesn't matter. Where's the solution curve increasing? Always. We're assuming the population is doing just fine. That they didn't get COVID or some horrible disease or get hunted to extinction. What values of the population, so how many bears, where's this concave up?
Always.
Before 1250. So for every question, it's concave up until half the max carrying capacity. These graphs always look like this. That y-axis can get shifted around. We can say, oh, well, we've improved their enclosure, they have more space, so maybe max capacity goes up, or maybe the K value changes and makes it steeper or less steep. But it's concave up till half max carrying capacity, which in this case, you're right, it was 1250, and it's concave down. So concave up 100 to 1250, and it's concave down 1250 to 2500. The justify your answer, that was asking you to do the double derivative. I showed you guys that once yesterday. You might want to try it on your own to make sure that you get the same answers. But part 5, yes, any other question?
How do I do the doubles? How do I find
Okay,
the
we'll do that now. So Amir, we're going to do the double derivative of this. What's the derivative of? Just rewriting it so that you see why it's implicit differentiation. Instead of PDT, change your population with time, and made it dy dx. What's the derivative of 5y with respect to x? Okay, so double derivative is 5 dy dx minus 0.0004 y dy dx. Right? It's implicit. Amir, does this work for you?
Yeah.
So unfortunately, over here, with it being population and time, it's the same thing. It's just harder to see that implicit differentiation. So I wrote it with the implicit piece on the outside because it's asking us to find the zeros, whereas to find inflection points effectively, where is it concave up and concave down, I'm going to find where concavity might change. So where is 5 minus 0.004 p equal to 0? And this we factored over here thanks to Camden. So where does p over 500 equal 0, and where does that equal 0? So my possible inflection points are when population 0, when population hits the max carrying capacity, and this one, one, two, three, four. How many times does 4 go into 10,000? 2,500. And getting that right or no? I got an extra decimal. I do, I copied it wrong. So now it's 250. 250 times 5. That's the max carrying capacity. So where is it concave up? Whatever population we started with, it's still the 1250, and where's it concave down? 1250 to 2500. No, actually. So I said this yesterday, if you know that where's the population growing fastest, half max carrying capacity, you can just say that. Unless they explicitly say, now prove it using a double derivative, which does happen every 5 or 6 years. But multiple choice, you can just say half max carrying capacity is where it grows fastest, or that's where the inflection point is, which is the next question. Does the solution have an inflection point? Yeah. We just found it. And technically I should check the number line to make sure that the second derivative changes sign. And I did the graph of it. All of the graphs look this way. This coordinate was 0, 100. Da, 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 da. And I have a horizontal asymptote at the top of y equals 2500. That's as explicit as I need it. But the one little thing I wanted to get at here, part B says, oh, these other people discovered this bear reserve when there were 1,500 bears on it. Does anything change?
Yes, absolutely.
What changes?
Well, first off, the maximum carrying capacity changes.
Does it? Does the max carrying capacity change?
Actually, no.
That doesn't. The solution range does, because the way this person that wrote the worksheet is like, well, I had 1,500 when I started, and it's only going up from there. Where is it increasing still forever? Where is it concave up? In this solution range, it isn't, because we're already past. We're past the inflection point. So this one, the solution curve looks like this.
So the inflection point is at 2000.
No, the inflection point is behind us in time. So there is no inflection point. That is the point of why they asked this. Is we got there, it's already past the Bears' heyday. They had the better times in the past. So Amir, it's just shifted. Part B, we came in here. There were that many bears. The inflection point is behind us in time. That's all this is asking you to see. In part C, we find them at 3,000 bears. What's that mean? Overmax. So it's overpopulation, and what's happening to the bears? They're killing each other. They're fighting over stuff, and so that curve, we've crossed the maximum, and it's going like this. I haven't seen EP ask for anything like this anymore, but again, this worksheet is from Nancy Stephenson, who is, in my world, famous. So, that she's making a point of it, there must have been a reason. Questions? Issues? Yeah.
So for B, they ask for an inflection point. Do you say what it is, or is there no inflection point because it starts off here?
it's considered no inflection point because in the solution range that you have, you got there and there were already a lot of errors past the inflection point. You're not gonna go back to the past.
So you would say there's.
Okay, so the rest of the worksheet, I'd like you to work on it with your partner, and if you have questions, let me know.